Problem 420 says that a sample of helium gas initially at 20 degrees Celsius and 1 atmosphere is expanded from 1.2 liters to 2.6 liters and simultaneously heated to 40 degrees Celsius. Calculate the entropy change for the process. We first start by rearranging the ideal gas law to calculate the number of moles of helium gas. We can plug in our initial values and we end up with an N value of 5.0 times 10 to the negative second moles. The key to solving this problem is to split it into two steps. The first step is to calculate delta S for an isothermal expansion from 1.2 to 2.6 liters at constant volume and pressure. For this, we use the expression delta S is equal to nR times the natural log of V2 over V1. When we plug in our values, we end up with a delta S for this part of the problem of 0.32 joules per Kelvin. Now we find the change in entropy for heating at constant volume from 20 to 40 degrees Celsius. For this, we use the expression delta S is equal to CV times natural log of final temperature divided by initial temperature. This can be rewritten as 3/2 times nR times natural log of final temperature over initial temperature. Again, we plug in our values and we end up with a delta S for this portion of 4.1 times 10 to the negative second joules per Kelvin. We can then add these two together and we end up with a total change in entropy of 0.36 joules per Kelvin.